RAG versus fine-tuning. Which should you use? Understanding the differences and technical approaches and knowing when to use RAG or fine-tuning can be tough. Each method has its unique benefits and drawbacks, varying in difficulty and cost. Choosing the wrong method here can lead to inefficiencies, wasted resources, and reduced AI performance. It's easy to get confused by the technical jargon and make costly mistakes, but this is one thing that is crucial to get right from the start. So let's review when you would use each. First of all, what is RAG? Well, Retrieval Augmented Generation, or RAG, combines retrieval mechanisms with generation models. It fetches relevant documents from a pre-existing database and generates responses based on this information. This is especially useful for large language models, which tend to have a cutoff date for training data some 6 months before, which is probably allowing time to prepare and train on that data. So imagine you have an AI customer support agent that needs to provide up-to-date, accurate, fact-based responses to customer inquiries. Using RAG, the agent can pull specific documents from a vast knowledge base to ensure its answers are grounded in up-to-date, relevant information. This approach is especially useful for fields like legal advice, healthcare, or technical support, where accuracy is key. Fine-tuning, on the other hand, involves taking a pre-trained model and training it further on a specific dataset to alter its behavior or improve its performance on particular tasks. We often see this with AI agents for brands that need to respond using the organization's predefined tone of voice. Fine-tuning allows you to train the model on a dataset of high-quality and brand-specific communications, ensuring the AI's responses are always on brand. Additionally, fine-tuning is ideal for scenarios where the AI must adhere to a specific format, such as generating medical reports or financial summaries or a specific JSON data structure. Now let's talk about the benefits and drawbacks. So the benefits of RAG are that it provides accurate answers because it gets its information from specific documents in a pre-existing database. To enhance the accuracy of responses, you'll need to ensure your database contains well-organized and verified documents. A great benefit here is that if the database is regularly updated, RAG can provide the latest information. However, it's often a manually invoked task, so you'll need to schedule regular updates for your database to include the most recent and relevant information. There are many databases or document stores that can be used for RAG, everything from databases like Postgres or BigQuery to PDFs on a Google Drive or a storage bucket. Even a list of URLs can be used as a RAG data source. RAG can manage difficult questions because it pulls detailed information from various documents. If you integrate multiple reliable sources in your database, you can enable the AI to pull comprehensive answers. Since the information is retrieved from verified documents, it lowers the chances of the AI providing incorrect information or hallucinating. Best practice here is implementing a robust verification process for the documents before adding them to the database. Now, the drawbacks of RAG are that setting it up can be complicated. It needs experts to combine retrieval systems with AI models and requires ongoing work in keeping everything updated. You need a team with expertise in both AI and data management to oversee the integration and maintenance of the RAG system, because RAG depends on a well-maintained database. The AI's answers won't be accurate if that database isn't any good. If this is a route you intend to take, then you should invest in building a comprehensive and high-quality database and set up processes to keep it updated. Now let's talk about the benefits of fine-tuning. Fine-tuning allows you to train the AI to respond in a very specific way. You use a dataset that represents the desired tone and style for the AI's responses and use it to fine-tune a pre-trained base model. By training the AI on data relevant to your needs, you can make it perform better on those tasks. This enables you to use domain-specific datasets, such as examples of text using the correct tone of voice, to fine-tune the AI for particular tasks to improve its accuracy and relevance. Fine-tuning ensures the AI consistently responds in the desired tone and style, which is essential for maintaining a brand's voice. You'll need to carefully review and update the training data to ensure the AI maintains a consistent tone and style. Customized AI responses like this can improve the user experience by making interactions more relevant and engaging. So continuously gather feedback and incorporate it into the fine-tuning process to improve the AI's responses. So what are the drawbacks of fine-tuning? Well, it requires a lot of computing power and time to train the AI, especially if you have a large amount of data. However, you could use cloud computing resources to handle large-scale training efficiently. However, you need to be careful because if the AI is trained too much on a specific dataset, it might not perform well on new, different data or requests. So you need to incorporate diverse and varied data in your training set to help the AI generalize better. Fine-tuning requires a deep understanding of the domain to understand the right training data and fine-tune the model effectively. So work with the domain experts to curate and prepare the training data accurately. And that's something that RAG and fine-tuning have in common. So how do they compare in difficulty? Setting up RAG involves combining retrieval mechanisms with generative models. This process requires skills in AI and data management. Thorough planning and design phases will help you to integrate the systems effectively. To keep the information accurate, the database must be regularly updated. However, you can use automation tools to assist with regular database updates and maintenance tasks. Fine-tuning requires significant computational resources and time to train that AI, especially for large and complex datasets. However, you can utilize scalable cloud infrastructure to manage the computational load efficiently. The dataset used for fine-tuning needs to be carefully prepared and relevant to the task. So perform thorough data cleaning and annotation to prepare high-quality datasets for training. Avoiding overfitting is crucial, otherwise you may find the model loses its ability to respond with expected content, but instead responds too much with your tone of voice or the sample data that you trained it on. So careful monitoring and adjustment of the training processes are needed. Cross-validation techniques, checking your samples against generated text, will help you avoid overfitting. Fine-tuning requires a deep understanding of the specific domain to select the appropriate training data and fine-tune the model effectively. So you'll need to collaborate with domain experts to ensure the training data is representative and relevant. Customizing the AI to respond in a specific way can be complex and may require multiple iterations to get it right. So use an iterative approach to fine-tuning, making gradual adjustments based on performance feedback. If not done correctly, the fine-tuning can lead to errors in the AI's responses, particularly if the training data is not representative of the full range of possible inputs. So regularly validate the AI's responses against a diverse range of test cases to ensure accuracy and reliability. So how do RAG and fine-tuning compare cost-wise? Well, when it comes to RAG, it depends on the size of the database. Setting up a robust database and integrating retrieval systems can be costly. This includes the initial setup and the infrastructure required to maintain it. So budget for the comprehensive development of a robust retrieval system and database setup. Keeping the database updated and the retrieval system running smoothly requires continuous investment. So allocate resources for the ongoing maintenance and updating of that system. If implemented well, RAG can provide highly accurate and valuable responses, which can justify the initial and ongoing costs. Conducting a cost-benefit analysis will help you ensure the long-term value of implementing RAG. On the fine-tuning side, once an AI is fine-tuned, it may not need frequent updates, which can reduce those ongoing costs. However, you should plan for periodic reviews to determine if retraining is necessary, balancing costs with performance needs. Fine-tuning can be more cost-effective in the long run for tasks that require a specific tone, style, or format, as it reduces the need for any ongoing adjustments. There are some cost-effective methods for fine-tuning, such as transfer learning, to help lower the initial training expenses. After the initial setup, the costs of updating the AI may be lower compared to RAG, especially if the domain of the application does not change frequently. So monitor the AI's performance to determine the optimal frequency of the updates, minimizing costs while maintaining effectiveness. The ability to customize the AI to specific needs can provide significant value, potentially outweighing the initial and ongoing costs. So focus on the value-added benefits of fine-tuning to justify the investment, such as improved user engagement and task efficiency. You can use metrics like accuracy, precision, and recall to measure and track the AI's performance throughout the fine-tuning process. Understanding the difference between RAG and fine-tuning can significantly impact your AI project success. So use RAG for accurate, data-driven responses and fine-tuning for customized, behavior-specific tasks. Apply our checklists and tips to make an informed decision and optimize your AI's performance. For more detailed guidance, feel free to reach out to the team.